All right, so we're going to look at a few applications of the law of sines. So I discussed the law of sines and I really built it up in my other video. So we're basically going to just use this for all these application problems. And I just have a variety of different applications. So let's just jump right into it. So an engineer wishes to measure the distance across the river. So we're, I forgot to put the second part of this, we need to find that distance. So here's a picture of a river, and let's say that the engineer has kind of sketched it down into this situation here, where the engineer knows that C is 117 degrees, 0.4, A is 30 degrees, and then B. So you should know what this little b means. So that means that we go to the side that's directly across from angle B. This is angle B, so I go across here. This is going to be 75.8. So I've got all of this information written out here. Okay. So we're going to use the law of sines to do this. So we've got angle, side, angle, so we can figure out some other information. So from this, I can figure out that angle B, I can figure out what that is by just doing the subtraction that you see here to get 32.6 degrees. So remember, I know these two angles, so take 180 minus those two angles. So B is going to be 32.6 degrees. And then to get this distance across the river, so this distance is going to be side A, little a. So I've got these two sides here, and now I know what B, angle B is. I just figured that out, right? And so B and little b. So I'm going to use this part of the law of sines. And then I just plug in my pieces, right? So I don't know what A is. That's what I'm trying to figure out. Got sine of 30, 75.8, and then sine of 32.6 degrees. So then you can just go through and solve all of this. So I've got now this calculation here. So this becomes 70.3 feet across the river. There are some applications with bearing that can come up. So just to remind you of the two methods of bearing, you can have the single angle or you can have the angle with directions. And so just how we kind of draw out those situations. So just a quick review of how that works. So the bearing of a lighthouse from a ship was found to be north 52 degrees west, and then the ship sailed 12.3 miles south, and the new bearing was north 23 degrees west. So to find the distance, we want to find the distance to the nearest mile between the ship and the lighthouse at each location. Okay, so we're talking about north 52 degrees west. So the ship was sailing, and so the ship is sailing, and the lighthouse is north 52 degrees west. So choose some point on this line. The lighthouse is somewhere over here. So here's north 52 degrees west. So my line goes north and west and makes a 52-degree angle with this north line. Then the ship sails south. So the ship sailed 12.3 miles south. So it goes this way. So this distance here is 12.3 miles. And now the new bearing to the lighthouse is north 23 degrees west. So from this point here, this is 23 degrees. Notice I go north 23 degrees west. My lighthouse is somewhere over here, okay? And, okay, so now I know this angle is 23 degrees, this angle is 52 degrees. I can figure out this angle here. So this line is 180 degrees. So if I take 180 minus the 52, I know that this gives me a 128-degree angle. And then I should be able to find the other corner, right? So then that's 180 minus 128 minus 23 degrees. So this is a 29-degree angle. Okay, and then remember, this side here was 12.3 miles. All right, so what we're trying to do here is we need the other two sides, this side and this side. And we've really completed the hard part of this, right? So it's always about getting that sketch. So we've got the sketch. You should really be able to finish this now using the law of sines, so finding the other two sides. So I suggest that you pause here, you try to figure this out, and then you hit play when you're ready. So I've labeled these sides A and B just so that you know what I'm referring to. So A, so it's adjacent, or its respective sine angle is going to be sine of 128 degrees. So these two go together. And then we already have the 12.3, right? And then I've got the sine of 29 degrees, so sine of 29 degrees and 12.3. So these go together. So then I can solve for A, doing the calculation you see here. So A is 20 miles. That's after I round it, by the way. So we've got three significant figures. So notice I've just rounded to respect that. So, okay, so A is 20 miles. So I've got one side down. So now I got to find this side B. And I just do the same calculation, right? So now I've got sine of 23 degrees and B. These two go together. And then I've got the rest of this calculation. So I can just set it up as you see here. And so I get that this comes out to 9.9 miles. So the rest of this I think is smooth sailing. Haha. It's a problem about a ship. Haha. Anyways, so it's I think it's pretty smooth sailing once you get that sketch right. One more application problem for you. A balloonist is directly above a straight road 2 miles long that joins two villages. The closer town to him is an angle of depression of 45 degrees, and the farther is at an angle of depression of 41 degrees. So how high above the ground is the balloon? This picture is not necessarily to scale, it's just a sketch to help you kind of visualize this. So you've got these two angles of depression, and these two towns are 2 miles apart. Okay, so we should be able to label all the pieces of this triangle here. So how do you get this angle? Maybe you should write that down. So to get this angle, I take 180 minus this 45 degrees and this 41 degrees, and that gets me 94 degrees. So that's this angle here. Now, thinking about transverse axes or transverse lines, you should be able to label the other two parts of this triangle. So I would recommend you pause, fill it in, hit play when you think you've got it, or if you're stuck. So this side here is 41 degrees, this side here is 45 degrees. So again, that's just using what we know from geometry. So I've got this whole side, or this whole triangle labeled. And now I can figure out, well, actually, here's the tricky part. So what are we trying to figure out? What are we trying to do? How high above the ground is the balloon? So what is that talking about? Is that talking about this side or this side? No, it is talking about this, the height. So this is what I'm trying to figure out. So we're going to have to use our noggin to determine this. This is actually kind of tricky. So I want to know this height, and what would be helpful is I see a right triangle being formed here, right? So what would be helpful is if I knew maybe one of the sides of this triangle. And I can figure out this side of the triangle pretty easily using the law of sines. So let me label these sides A and B, just so that you know what I'm referring to. And so what I'm going to have here then is sine of 45 degrees, A over sine of 45 degrees, so these two go together, right, equals 2 over sine of 94 degrees. So I'm leveraging kind of the greater triangle right now, and I can figure out what A is. So I just went ahead and I think you guys know how the calculation here works. So this side is 1.4. Okay, now here's where you got to put your thinking cap on and try not to make this too complicated, which like I think this is actually the really tricky part of this, because you're like totally on fire about using the law of sines, right? Well, in reality, so I'm trying to figure out this side here. Look at this. This is a right triangle, right? I don't need the law of sines to figure out H now. I know a side, I know this angle, and I want to figure out this side. I can do that just using the good old sine function, right? So sine of 41 degrees, opposite over hypotenuse. I know the length of that hypotenuse. So that I think is the tricky part. So you can fill in, that information and solve for H as you see here. So sorry, I jumped a couple steps. But what I get now is H is 0.918 miles, and then you can round that as needed. But anyways, so that's how you get to the height. And so you have to use all of your knowledge of trig to get to that. And all right, so that is the end of that. So that used the law of sines. Thanks for watching, guys. I'll catch you in another video.